This is problem 21 from chapter 4, and there's a genre of problems where some objects, they fall some distance, and here's a person falling, right? That's my drawing of a person, right? What? Oh yeah, I know, they jump off the house, right? And they drop 4.5 meters, right? And then they are stopped in 0.70 meters. And the thing you've got to realize is that there's two parts to the problem. There's it free falls 4.5 meters, and we got to figure out what speed it hits, right, their legs in this case, right? And then for 0.7 meters, it's going to accelerate up. So here it accelerates down, here it's going to accelerate up. Is the upward acceleration or the downward acceleration greater? Upward, I believe, is going to be a lot more, right? The one that stops it. And the reason I know that is that it's happening in a shorter distance. What if it happened in the same distance? Would it be the same then? I think so, wouldn't it? If you speed up for the same distance and slow down for the same distance, I think your acceleration is the same. If it's half the distance, is it twice the acceleration? I don't know. We'd have to look at the math of it, right? Okay. Can we just do a proportion? We'll try that, you know. Okay. So the first thing to do is to Suvat this, and I think the final velocity, we're going to use v squared as u squared plus 2as, right? And the final velocity is going to be, the initial is 0, right? 2 times negative 4.5 times, 2 times negative 9.81 times negative 4.5, right? And then it's going to be the square root of that is the absolute value of v, right? So we've got the square root of 2 times negative 9.81 times negative 4.5. And I'm getting 9, is it 9.396? 627, blah, 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 right? Okay, meters per second. And I'm going to say that the final velocity is negative, that they're going down when they hit it, right? We should, by the way, come out with, when we Suvat this part here, okay, when we Suvat that, we should end up with a positive acceleration. If you don't, make it positive, because you know that to stop going down is an upward acceleration, don't you? I'm hoping you do. Yeah, we know that. Okay. So now let's Suvat this part here, right? For this part, Suvat, what do we know? 0.7, do we go down 0.7 meters when we stop? Our initial velocity is negative 9.39627, right? Okay, final is 0, there we go. And we want the acceleration. We don't give a hoot about the time, right? Okay, so I'm going to use the same formula. I'm going to use v squared as u squared plus 2as, I think. Yes? Okay, so if v squared is u squared plus 2as, then a is equal to, what is it? V squared minus u squared over 2s, is it? It's like do the math and then see if it's right. I think that's correct, yes? That's not 25, that's 2s there, yeah? Okay? And so we can plug those numbers in. For this guy, it's going to be 0 squared minus 9.39627 squared divided by 2 times negative 0.7. Is that going to end up being positive? Yeah, numerator is negative, denominator is negative. So that guy squared divided by 2 divided by 0.7. 63.06. Okay. Take a look at this too. Okay. Do you see that there's a direct or inverse proportion between acceleration and stopping distance? You see that? So it seems to me we ought to be able to set up a proportion and get an answer to. I don't know. We'll find out. I'll stand away from that if we get the wrong answer. But we ought to be able to solve this using proportions somehow. Yeah? To find out what this acceleration is. In other words, 0.7 is to 9.81 as 4.5 is to this acceleration here, right? Let's try that. 9.81 times 4.5 divided by 0.7. Hey, that gets the same answer. That's kind of cool, isn't it? In other words, if I set up a relationship like this between this distance and this, and the acceleration in this part and the acceleration in that part, I get the answer. That's kind of cool, isn't it?
Way easier.
Are we done yet?
No.
No, what do they want? They want to know the force needed to accelerate basically this box upward at 63.06. Now, why is the answer? This box, by the way, has a mass of 45 kilograms. Why is the force, though, not 45 times 63.06? People are going to do this. On the test, people are going to do this. Okay, they're going to calculate an acceleration, multiply it by a mass, and write it as the answer to the force, and they'll get it wrong. Why? Why is that not the force? Because of gravity. Okay, so now let's draw a picture of this guy as it accelerates. I need a little more room. There we go. Okay, let's draw a picture of this guy as it accelerates. The box is accelerating up at 63.06 meters per second squared. It's 45 kilograms. How do we figure out the force needed to do that? Well, the unknown thing is the force, right?
Yeah, we also so it's force minus 9.81. Well, plus 9.81.
Okay, be very careful. What's the downward force? It's not 9.81. What is it?
You do 45 times.
45 times 9.81. So 45 times 9.81. So the force down is 441.45. And that was 45 times 9.81, right? Okay. Now what's the next step? Unknown force up, known force down. The upward acceleration is 63.06. We do that formula. We do Newton's second law, right? Okay. So Newton's second law looks like this. Force minus 441.45 equals 45 times, no, what's the acceleration? Positive 63.06, yeah? Okay, so every step of the way you've got, why is that negative? Because it's gravity and it's down. Why is the unknown force positive? Well, because we know it's up, but you always make unknowns positive, right? Why is this guy positive? Because it's an upward acceleration. Were it accelerating downward, you'd make it negative, but this one's accelerating up, right? Okay, hopefully this gets the right answer. So this is the answer 3279. What's the answer? Is that the right answer? Yeah? Okay. There we have it. Are we good with that?